I know it's a afternoon session, so it's always a challenge all the time, right? And I'm privileged to have been invited for this session and to moderate this session. I have with me Dr. Wagh, and he's the Provost for UPL University, and Dr. Mangaleswaran. He's with currently with DCM. Earlier, he worked with Deepak and Solvay. So this particular session is on lab innovation and applications and sustainability. So as we all know, lab is a relatively small area compared to the manufacturing and all that. However, it's a little bit confined space kind of area, and there are safety challenges, there are issues where exposure of chemicals is quite a bit with the people who are working in that area, right? So, so that's a background, and so I will just start with, on the various topics. There are a number of topics like, emerging lab innovations, applications, industry and academia collaboration, and what are the challenges that may have happened, and what are the challenges we are facing from innovation to commercialization. So how that can be streamlined, right? So in that case, I would start with question on the emerging lab innovations. So maybe I will start with Dr. Mangaleswaran. From the industrial point of view, you have worked with various industries like MNCs and all that. So what are the emerging lab innovations you have been seeing all around so far? And what is the future from the industry perspective you would like to give?
In my journey of 20 odd years, what I've seen from the academic lab, the industrial lab. So the initial audible? Yeah, thanks. So the journey I've seen in the last 20 years, it's tremendous. Initially, the lab setup was very manual, and you have to deal with a lot of manual work. Now, if you look at, I'm currently with the DCM Shriram, and previously with Solvay and Deepak. So the lot of digitalization things are happening now, from the lab equipment's automation to the analysis aspects. So as Mayank rightly pointed out, there are a lot of online tools that have started coming. Earlier, it used to be a kind of submit the sample and wait for the analysis. So when I started working in an industrial setup, I think there are a lot of good PAT tools are kind of coming up. So initially, I was working with, I've seen the pharma industry, which was hesitant to adopt. They also kind of adopted this kind of a process analytical tools. So which is kind of very on the go, you can get the results and you can take a decision. Instead of a quality by analysis, you can always get the results online, and then you can make a decision very fast. So these are the, I think, digitalization and then continuous online measurement of your process. It's kind of shaping up well. So with this, I think there are like emerging technologies like batteries and then semiconductors. Again, you need a very high pure materials kind of requirement. So that work is get started in the lab, because in the lab, you need to get the right quality in terms of the metal content purity and all. Because the semiconductor materials and then electronic grade materials, they are kind of very specific or very sensitive to the, the metal impurities will affect your downstream processing. So I do see that these are the upgradation of our lab equipments definitely helping the overall process development. So I think with that, I think we would like to add any points from in terms of the academic perspective. So any sustainable technology or so.
Well, initially Dr. Mayank has very rightly pointed out that laboratory is a very small area. However, it is the most important area as far as industry is concerned, as well as any academic institution is concerned. I being from academia, we also find that laboratories are really very important, although they consume a small space. In this, I recall here one exquisite shloka from Srimad Bhagavad Gita. It goes like this: Neha bhikramanashosti pratyavayo na vidyate swalpam apyasya dharmasya trayate mahato bhayat. It means that if we start any work, it never goes into a waste. At the same time, nothing happens in opposite direction if we do it appropriately. And if a small care is taken, it is never wasted. It pays in return. Laboratory is the small karma bhumi. For it may be an academia or for an industry. So if we follow certain norms, that in laboratory, and then that is reproduced in the bigger karma bhumi, that is your plant, then it will pay great dividends. I am actually referring to safety. So when safety norms are properly followed in laboratory, then it also helps us on the plant or on the shop floor. This particular training has to be given in the laboratory itself. As Dr. Mangaleswaran also told about automation and things like that, to have the advancements in the lab techniques, it is really very important that new automation techniques should be employed. Gone are the days when volumetric titrations used to be the important kind of analysis done in laboratory. Now in this thing, academic institutes also, the laboratories are equipped with AI tools. Now AI tools is something which can bring innovative techniques. Only what it needs is proper data to be incorporated. And huge data are available on research sites which are freely available. And our computer engineers and computer technologists can use these data to make AI tools. These AI tools can be really used for training machines. And these machines can be used for automation in analysis or in our laboratory. That will reduce greatly the safety points or safety problems in laboratory. Needless to say that if we take it up to the bigger shop floor, then the safety aspects will be properly taken care of. So in connection with this automation point of view for laboratories, we should train our laboratory people to take care of the smallest aspects of, say, analysis, then consumption of chemicals, consumption of energy. Although they look very small, but they are really very important. So that's my view about this.
Thank you, Mangles and Dr. Wagh. So, I mean, you mentioned about AI, and AI, I mean, you are talking about AI for the instrumentation. In that case, do you see any risk per se for the human being in terms of employability of the people?
Not at all. Because although it is artificial intelligence, but what fundamentally goes into it is natural intelligence only. So people are required. People who are properly trained. People who know interdisciplinary things. For example, it is not job alone of a computer engineer to develop an AI tool. For example, if we think about a chemical laboratory, then a computer engineer alone cannot do or cannot make an AI tool to operate. He has to have, or he has to fall back on a chemical engineer or a chemist for that matter. So therefore, in our university, we keep on discussing these things. And that's why in our university also, when we have started our PhD program, we have made it interdisciplinary. Means a chemistry person can work on a chemical engineering topic and vice versa. So these things are now going on and are well taken care of. And for that matter, we are also joining hands with our computer faculty members so that they can utilize their computer knowledge in developing certain ML programs or algorithms or AI tools for, say, laboratory techniques or for research methodologies.
Thank you, Doctor. Mangaleswaran, so taking that same to further, what are the automation or what are the digitization that can help us at the laboratory as well as, at the shop floor, which will certainly, enhance reliability and of course, technology transfer to the plant, I would say.
So earlier the documentation happens manually in a notebook or so. Now having the e-lab notebook, for example, it's a kind of a, most of the organizations in industry we adopt that. So the lab experimental entries are entered online and it is being shared across the different team members, starting from lab members to other stakeholders like analytical person or the technology transfer person or the, your technology partner. So this information is shared on a live manner. So this decision or the knowledge integration happens very fast. Otherwise, this was a big deal earlier times. So I think that's the digitalization enables us to be for the faster product cycle. So that's one thing I myself witnessed in my journey. And also there are, like, as the Provost sir was telling, Wagh sir was telling, that AI is enabling our innovation process. Exactly. So in the material research development, currently is that there are a lot of AI plus image processing, AI plus you have a knowledge integrator kind of thing. So that fastens the overall product development cycle much faster. So this is kind of a blessing at this point of time. There we kind of faster way of putting the data in and also getting the data with right insights. So this really helping us in a lot many ways. So I think, as Dr. Wagh suggested, we should empower or we should teach the current generation or the future generation with lot of digital literacy, because some kind of programming languages and other aspects should be kind of integrated with chemistry and other research curriculum. So that will help us in a tremendous way.
May I tell you something about, say, new education policy, the national education policy which has now come into force? It emphasizes on this particular fact that interdisciplinary research and interdisciplinary education should take place. It is not like that we are confined to one domain of our education. I may be from, say, science background, but I must learn something from our cultural heritage. I must learn from the scientific advancement which has taken place centuries back in our country or elsewhere. So that gives an impetus to our faculty of brain that what new can be done and how the things were there during those times and how the humankind has made a progress. So that gives us some kind of idea to our young generation that how the thinking process should be there. So that greatly helps. So this new education policy we have been implementing slowly in our university also, and in many universities they have already started. So this will create the real new generation which will have thinking, which is global thinking, touching many fields at the same time, and thus the interdisciplinary research will be facilitated.
Thank you, Doctor. So so there is always a complaint from the industry that the people who are coming out of university, they are not employment ready. So what are the ways you or your university is making sure that, the engineers and chemists and, they are ready to be, employed successfully and faster way into the company they are going towards IVETS.
I hope you are talking about students.
Yeah, sure.
Actually, our history of last 6-7 years tells that we have got 100% placement across this area. Means whosoever graduates and wants a job, he gets a job, thanks to all industries who are helping us all the way. So there is no such fact that students are not ready for employment. Yes, I must say here that they are looking forward to having good package, so which may not be available at all industries. Of course, industries have their own views of, say, starting salary or things like that. But our students are happy with industries, and we have seen our students growing in due course of time. Initially, they may not get good salaries, but after 1 year and 2 years, they have very good salaries, and they are really happy because we have a very big alumni association, and we are in contact with all our alumni. So they always talk about, in high words, very respectable with their industry employers.
Okay. So now let's go to the sustainability part. I mean, Dr. Mangaleswaran, you have been involved with, as I understand, green catalyst and bio-based materials. So how do you see the development of, green catalyst and bio-based materials replacing fossil derived chemicals?
So of course, I think I got involved in green chemistry somewhere around 10 years back. But that time the ecosystem was not as good as now. That time the ecosystem was very not supportive in terms of the funding, in terms of the idea acceptance and all. But currently with all these changes happening, decarbonization, and then everybody is promoting low carbon emissions, and then these definitely help us. And this is what the current considering this and what I see, the carbon credit rating for the products which are low carbon emission and all. So it's definitely going up. But compared to Europe and US, we have still a lot to overcome because of the competency gap, and also we are a cost sensitive business model what we have here. But still, as with the academic help and also with some right technology partners, and particularly even petrochemical industry, I would say, they also develop sustainable chemistry products because they use a lot of catalysts, heterogeneous catalysts, which doesn't involve any solvent, and which doesn't, all the mass is utilized. So in a way, they also do a lot of good sustainable chemistry. Only thing is the input is a fossil based. So similar approach can be adopted for bio-based materials, because both are in a way slightly differentiated in terms of structure, but the approach can be the same. That's what a lot of pyrolysis process of biomass is happening. And then you have a bio-based materials. Even in DCM Shriram, which I am part of it, we have started the epichlorohydrin production using bio-based glycerol, which is done on a 1 lakh ton scale. So that shows that bio-based material is kind of comparable with a fossil-based material. Of course, it is in some cases it is really comparable. Even polylactic acid, for example, lactate is derived from biosource, corn-based. So in Thailand, there is almost 50,000 tons to 1 lakh tons plant has been started. So there are like a lot of good sweet spots are there, and a lot of new things are coming up. But the thing is that fossil-based technology developed 100 years back, so it has got a lot of maturity, technology maturity. But bio-based material, it has to go, it has to travel its own path.
Right.
So, but things are encouraging, and I think we will have more bio-based materials will coming up, because in sugar, I'm also part of DCM Sugar, which also converts a lot of sugar waste into valuable products. Potash alum is the one product we recently launched in the market, and also bio-CNG produced from agro waste. So these are like really, I think, worthy projects I can mention.
Okay, doctor, you want to add anything like what ways in academia can help us like the industry from conceptualization to research at the laboratory in the academic universities, and then help industry to realize that, and what are the product lines at your university or your group is working on this particular line?
Yeah. In fact, in our university, we have handled a few projects which have helped industry. I'm happy to share with you that one of the projects in which the paint sludge has been converted into a primer. Now it is being commercialized in Himachal Pradesh. So extensive research was done on this project, and now it is on the stage of being commercialized. Another project is with one of the industries in Jhagadia in the treatment of organic waste. So we have successfully dealt with that project in economically recovering important heavy metals from that. Then one of the DST projects which we have got in collaboration with industry BEIL, and DST has funded us say about 56 lakhs rupees, and we have developed a pilot plant to synthesize a biopolymer. See, this biopolymer is actually extracted from the waste sludge of the industry, and we have made a process for that. We have of course got a patent on it, and many such processes are there. For example, from COD wastewater, we could extract silver and mercury, and we have got a patent for it. And for industry, we have helped it. So they can, we have converted that mercury and silver into usable salts, which they can further utilize in their COD analysis and environmental laboratories. So thus, this is a list of some projects which we have dealt with and successfully rather dealt with for industry. And there are about a dozen of projects which are now, we are working now on it, and most of them are from industry, and many of them are related with environmental pollution abatement as well as wastewater analysis.
Okay, thank you, doctor. So government, as we understand, government is also putting a lot of emphasis. They are also providing a lot of funding, I believe. So if you want to talk from the academic point of view, as well as maybe if there are, for the industry, colleagues can be, made aware of.
Actually, government wants it that the academic institute and industry should come together on research projects. So that's why the new scheme which has been floated by government talks about industry collaboration with industry, specifically on certain topics like research in hydrogen synthesis, hydrogen transportation, hydrogen storage. We have also sent our proposal for that. Another area is that of treatment of battery. So that is another area where government wants industry and academic people to come together. And the third area is about semiconductors. So there also huge grants are available. Then one of the most important things is low carbon technologies. So that is also a research area where a lot of incentives and research funds are available from government and agencies like DST, then Atal scheme, and even AICT, and small organizations, I mean small funding organizations like IICHE, all are working in this field, which give good funding and good encouragement for these new areas of research. So our people are also trying in this field. Even generating oxygen from electrolysis of water, that is the field where a lot of research is now happening.
Okay. Doctor, if you want to add from the industry perspective.
So from industry perspective, I think there should be some kind of a common interest between industry and academic partner. Currently, government is promoting a lot of biomass-based projects and then, as Sir said, hydrogen, clean energy kind of thing. But in that, again, what I see is both parties should get benefited out of this, because otherwise what will happen, it turns out to be either academic or industry kind of projects. I think it should be a kind of a common interest, and the academic partner will enable this project, and then the industry partner will take it to the next step and then commercialize it. I do see a lot of developments, particularly in Bharuch area. I visited a bio-CNG plant which is kind of converting all, they collect all waste foods from, all the restaurants and all, and they convert that into an effective way of converting to, bio-CNG. And they are doing it on a kind of 80 to 100 metric ton per day, very efficient way. So in that, I think they are enabling this process in terms of converting waste to a kind of energy, a useful energy or a bioenergy, you can say. Like that, I think we should find more opportunities that academic and industry should collaborate and then, find out those opportunities.
Okay. Yeah, I understand. I mean, so point is that, I mean, as previous panelists also, talked about that ultimately the resource has to be, not only ensure that we don't overuse it, we should ensure that they are recycled, reused, and reduced to use, right? And so in terms of from cost perspective and the challenges and limitations from scalability, from transferring lab innovation to the commercialization, do you see any how you are able to tackle this from the sustainability point of view? And as they say, there is a limited access to funding for early stage sustainable R&D in smaller labs. So how you can tackle those challenges?
So one particular example I can tell where we had converted a heavily cost intense and then effluent intense process into a cost efficient and sustainable. But obviously the key roadblocks are the technology development, because the technology available in the West, for example, is not available in India at this point of time. And that technology provider also kind of charges heavily on this kind of technology. So I think academic and industry should work together to develop such kind of sustainable technologies so that we will be independent, and then we don't rely on the technology, particularly from the Europe or US based companies, where the cost is going to be significantly higher for those kind of technologies.
Any thoughts on that, Dr. Wagh? I think biogas is an area where academic institute and industry can come together for mutual benefits. Academic institutes can find out new ways of producing biogas from different feedstocks. Actually, these feedstocks have a great impact on the amount of methane the gas generates, the biogas generates. And depending upon the area where the industry is situated, the type of feedstock is different. So therefore, there is a great need of doing research in this area, that what feedstock gives what quality of biogas. Of course, the intermediate anaerobic digestion processes are very important, but it will also give an idea about what kind of microbial culture which must be developed, cultured and used in certain processes. So that is really a very fertile area of research from academic point of view. And I'm sure that some or other research will fructify into some profitable process in producing biogas, so that can be later on used by industry. I'm very much agreeable to this, that industry always wants things which are profitable, but it takes little time for research to take place and fructify into a commercial process. So industries, I hope, will give that much of time for this, because now biogas is an area which needs a lot of research on several dimensions.
Okay, yeah. So, any policy incentives we can think of, for labs to adopt low carbon or green chemistry technologies? I mean, what can be suggested from your perspective, from the academic perspective also, as well as from the industry perspective?
From academic as well as industry point of view, what has been proved is for this carbon capture, the gas absorption technology is the most important and has been widely used. And now also it is being used across industry. But in that, what is important is the solvent. So the solvent, now latest research is taking place in this MDA plus piperazine type of solvent, that is methyl diethanolamine plus piperazine. So this solvent is being researched out at very big institutes regarding absorption efficiency, the absorber design, and the mechanism of absorption. Similarly, AMP is another solvent which is also being tried with piperazine for testing its absorption efficiency. Traditionally, ethanolamines have been used in absorption, but newer solvents have to be searched, and which will these solvents should be green, or they should be obtained from green sources if they are not really green. So gray solvents would also do. But in this field, new research must take place, and I hope industry will come forward to do certain research in this area, which would create new pathways in creating green solvents or newer solvents which can be commercialized.
Thank you. Mangaleswaran, if you want to add.
So, of course, in industry, we trying to convert all byproducts or use byproducts into useful products. That is one way of converting a waste to wealth kind of aspects. So, but still, as there was a meeting in the morning, that there are like lot of regulation from the regulatory authority of converting waste into wealth. We have to overcome all those challenges from a regulatory perspective. So that one aspect also we are working on it continuously, and then make that value proportion of the all byproducts. And also as a part of, as a byproduct from sugar and byproduct from our chloroalkali plants. So continuously there is continuous value addition, and value addition always brings in the, better efficiency use of energy. So in that way it's a continuous progress is there. But still, as Sir said, there are a lot of scopes in that also.
Okay, so I would add. I mean, in terms of, I think this session, we will close it with one last question. That what are the opportunities and future directions we are seeing in terms of, lab innovation and commercialization of lab breakthroughs, both to Dr. Wagh as well as, Dr.
We will have to give up the old lab setups. We will have to come up with new lab setups which are well equipped with AI tools, automation, and safety aspects, because the age which is now coming has to deal with hazardous materials like hydrogen, then we will have to pyrolyze waste materials which has got a heavy potential of hazard in it, then batteries, lithium-ion batteries, and which are to be replaced in future by sodium batteries. So all these materials which have to be treated in the lab are full of hazardous things. So the conventional laboratory setup may not work. We will have to find a new way of constructing even the lab. For example, if we think of a separate hydrogen lab, so then hydrogen lab has to be properly designed. Now this design must take place with the newest software like Flax, which has been developed by a doyen of safety consultants, Gexcon from Norway. So they have developed a 2D and 3D kind of software, and this 3D software design is a must for the lab like that of hydrogen, because we cannot take risk in case of hydrogen. So proper design must be done. 2D cannot give that design. Only 3D QRA, that is quantitative risk assessment, has to be done in this type of research, because hydrogen in the smallest amount is also equally dangerous. So for that matter, the new lab designs have to be properly worked out, and it would of course require some money. I hope industry would come forward to give some money for this thing to academic institutes and help research take place.
Okay, point well noted, Doctor. Dr. Mangales.
Yeah, I think the way of working will be more digital in the upcoming years, because what I see is generally in industrial product development, innovation product development is done in a stage gate process, and every stage gate process the knowledge is shared across the team. So the more digitalization, it will help that this process faster, and then data integrity is also very important, and also the securing IP is also important. So this way digitalization is going to help, and it will be the way forward. And also sir mentioned the way of in terms of the lab infrastructure. I think the difficult chemistry, the hazardous chemistry, what we are doing currently in industry on batch process, slowly will be converted into a continuous process. To adopt that continuous process, the necessary infrastructure should be in place. Even I have had a lot of challenges to make this happen. We made these changes in few products, but it's always a challenge to bring in those infrastructure unless the ROI is shown to the management. So as you all know, so bringing in money to something without any return is also always a challenge. So, but once you do this and once you show some success stories, management would be ready to invest, and this is kind of a benchmark for the other teams to follow, and then as a company to follow. So this is a kind of hard work, but if it proves successful, I think that this will help the overall ecosystem. So I think everyone is working for it. I think the digitalization and then automation of lab infrastructure, so those things will definitely is a way forward, and those are the upcoming trends, I would say.
Thank you, Doctor. So I think the floor is open if there are any questions from the August audience for both of our, knowledgeable people from academia as well as industry.